Hello. It's time to grind. All right. Chord, raise, error, debug. Okay. Range cut off. Yeah, so I don't need arm anymore, I think. Oh, no idea. And for flank and range 13. That seems about right. Alright, we have all this down. Okay, so you initialize the next in 7th order and 8th order. I'm very confused with Python, because I don't know where the variable actually starts. Okay, so I don't think we need this anymore. Just comment that out first. Equals y for y and y this. Okay. So y this. So it's the same thing? Okay, sure. We can just do the y this dot duplicate. If that works. That seems like the same thing. Okay. Full implementation so far. This episode, we'll see the This is basically a duplicate function, I think. Called car. Imagine. Okay. This one's pretty self-explanatory. Butcher tableau. Okay, this doesn't exist yet. Yeah, so we have to put this together. Some assembly required. Actually kind of surprised. This is the butcher table. I think he cleans them up here. Yeah, that's B43. So we have the butcher table here. I'll just label this as same. Okay. So that should work. So that directly translates, which is a good part. That's BI. Bar xi equals x. What's as? Is this a thing? Oh, okay. FMT off. Okay, so this is nice. I equals y for y and y this. Isn't that basically just y this? This part's a lot. This part's a lot easier than what is needed. That's possible? Kinda crazy. Yeah, so it might be a bit less accurate than what's implemented so far. So that's pretty interesting. Okay, so let's take all of this, push that up. Yeah, so I have this written down. I have a screenshot of it, rather. Or in range. YR. I'm actually kind of ambiguous to see what this goes into. This one goes to 12, I think? Hopefully. Yeah, I don't remember. To go for loop. I want to see the for loop behavior because I don't remember. I'm very scared. Okay, so there's one less. That's good. So no unexpected types of behavior there. Okay, so that's how that line works. It's a much more complicated line that we only had before. Oh, XI YI H. After the loop, YI is the new. Okay. Oh, this is also a thing. We look at XI. Okay. So DI is a thing. Okay. Six, 7, 8, 9, 10, 11, 12, 13. Or I and okay, that's how that works. Potatoes. That's a number? Okay. Yeah, it's a vector. Okay. How big is DI? Okay. Let's do another memory allocation. The best Hong Kong producer right now. CSI. What the hell's CS? Where did CS come? Oh. Give me a minute. Give me a minute.
いつからか忘れていた苦手なコーヒー砂糖とミルクでも変わらず苦いのにあなたが残したその匂い思い出すたびに少しだけれど飲みたくなるわかってるのいつもそうなのわがままな態度わかってほしいのそのすべて建前に過ぎないよ勘違いの繰り返し間違い探しじゃない君の
disappears. Is wine next? Okay. Oh, thanks to one handy translation, I'm actually able to do stuff. That's a vibe. Joe.
「
Look at me. Hey, bring to G's. What's up? Well, it's chill to me in my current state, so it really depends on what's happening that day. But how are you doing, man? I do not believe I've seen you before. What's this one? So K represents KI here. Okay, we're done this part. Yeah, this is one of my favorite artists. Main reason why it's big, it's basically modern classical. Modern Baroque? Baroque style electronic with actual good vocals. Do they have Y-hat? Alright, let's just take this here. Oh, you're recommended? Oh yeah. Hey Brian. Alright, so yeah, this is Rixas. Rixas is a insanely complicated grand strategy game. I just recently got a new team member on board, Phoenix. I don't remember how to pronounce... What's his name again? Yeah. Jinping Jai. Jinping. I don't know the pinyin for that, so I'm currently implementing some of his work. And we're doing, what's it? I remember, yeah, it's pretty new to me. Because I don't have to do this, but yeah, Runchkuda Bellberg of 7th or 8th power. So I'm just upgrading the current analysis functions. So currently, let's look at some of the game aspects. So yeah, the current part I'm running right now is pretty independent. But yeah, there's quite a few features. So we have a full small arms designer. So here we can start from the propellant. You can choose the composition. So there's quite a few. There's a few to choose from right now, and it's based on these stats: adiabatic, frame temperature, co-volume, density, such. And then choose your composition, of course, and the geometry. Perforations, and this affects burn rate. And then what happens? We get to the cartridge. Let me pull up an interesting cartridge here. Yeah, so here, yeah, of course, you have to customize the projectile itself. The shape, jacket. So the jacket's really interesting. So jacket is what engages the rifling so that the projectile can be stabilized. So if you understand a musket and why they changed from muskets to rifles, it's because of rifling technology and how to actually engage that rifling to impart that stabilization. Yeah, length diameter. You can turn into a shell if you want. And the casing. And here with this type of materials, you can see here's a full list for you to choose from. Yeah, so these are all standard American engineering numbers for the alloys. And these are all different alloy compositions. So 4140, for example, contains chromium molybdenum. So that's why it's really popular in firearm design nowadays. Back then it was a bit harder to produce, so it also, Rixas goes through the tech tree of how these different materials were processed, produced, material scarcity, stuff like that. And yeah, stuff you have to care about, density, yield strength is very important. Safe use temperature is of course also very important, because you don't want things to overheat. Yeah, so all this is in metric. So everyone here can understand. And of course, you load the propellant in here. Primer, that's how it ignites. Rim type, and those dimensions there. Once you go that, now we can actually start kind of building the meat of our firearm. Let's just pull up the emulsion for an example. So of course, you need the composition, the type of action, safety, magazine, production method. This is really important, because especially early on, stack technologies weren't really reliable, so that's what this is. We have this thickness, rotating bolts. So these are all different interesting components. Once we go through there, we have a barrel. And what's interesting that you'll see about the barrel, yeah, of course, composition, material thickness, length, also rifling. So I mentioned, yeah, this is a strategy war game. This is a grand strategy, yeah. But one of the main selling points is that you're able to customize most of what's happening. So this rifling, this determines how much rifling there is, and that matters quite a bit. So we get to one of the main aspects, which is the firing range. So let's take this for example. So my receiver, barrel, that all fits together. And what's my shell for this one? Yeah. So this is my armor-piercing shell that I designed pretty painstakingly. So we can start seeing some stats here, which is muzzle velocity. Yeah. So you can see that my rifling is really off for this barrel, because it's spinning way too much. Spinning too much in Toodle is a big problem, because if you spin too much, you apply too much radial force, and that can cause your projectile to disintegrate, which is not good. Peak pressure, barrel spread, this is from the harmonics when it actually goes through. So actually a common misconception is that some people think that a longer barrel is more accurate. This is actually not the case. It's not the case if the projectile has already undergone a full spin cycle in the rifling. Actually, shorter barrels are more accurate. It's just that you need long barrels in sniper rifles, for example, because you need to impart more velocity. Because that's when your cartridge burn actually goes all the way through, so you can actually use all of your propellant. Yeah, so you can do a little test here, which is a bit fun. A lot of different design that works better. Whoops, that doesn't work. So yeah, this is the Belf A. So for example, if I go here, and I put in, let's say, 4,000 meters at 10 increments. So yeah, speed of sound and air density changes from place to place, and that affects your aerodynamics quite a bit. So wait for that to process. It's taking quite a while. I guess it can't go that far. That's weird. Okay, well there's a problem for some reason. Let's see if changing that fixes anything. Okay. Let's call this out first. Yeah, so once we see that finished processing, we can see, so the different colors represents different lethality ratios compared to soft targets. So we can kind of see the aerodynamic drop-off. And what's interesting about aerodynamics, especially for bullets, is that it's not linear. There's actually 3 different distinct stages, like hypersonic, and then sonic, and then subsonic. And those have, the shape of the bullet really affects like the aerodynamic drag in those different parts. So that's why it's quite difficult to simulate in FPS games, for example. That's why FPS game firearm drop tends to be very, very linear. So let's go back to our armor piercing design. So I just wanted to demonstrate those nice coloring. So for example, 1000 meters, let's go back to our testing conditions. Pretty typical. Say 10 degrees. So here we have a nice little armor test. And there's actually quite a few different, this is called terminal ballistics. Or what happens when there's actually contact. Yeah. So what happens here is that there's different ones. So this one's plugging. This is when it's much thinner. So once we up that thickness, you can see that becomes piercing, which is a typical mode. And let's see, let's try to stress test it a little bit. So it's pretty usual for something to be able to penetrate itself at. Yeah, so once we get here, we can see the pedaling mode activate. This is usually a pretty indication of a low chance or low probability penetration, because a lot of force is required to do that. So you can actually analyze this in the game. So when you see wrecks of your opponent's vehicles, of your vehicles, you can kind of guess what happens. And of course, at high angles, at a ricochet. That's a bit of a low chance, especially for this one. And also really depends on nose shape. If you look at development of armor-piercing rounds over time, then you'll see the really interesting cat and mouse game that they had to play when it comes to high impact angles, making sure the penetrator actually survives. So you actually won't see armor-piercing penetrators have the same shape as you do like a small arms round. And that's where caps and stuff come into play. Once you finish that, you can go into the loadout designer. So loadouts for individuals troops, and you can squad designer, company designer. I actually don't have an example company on this computer. But yeah, there's a nice company graphic. That doesn't work. But yeah, that's kind of the gist of what the game's about now, so... There's also a map as well. I forgot to mention that. And also right now, currently you can design crates too. Because this game will have a living, breathing rear line. It's very different from games like Hoi 4 or War on the East, in which all of your support units are actually physically represented and they're actually doing stuff. Yeah, so here's just a basic map. It's pretty nice. Yeah, so the graphics are definitely not there. But this game's not, it's really not reliant on graphics to kind of sell itself. So if you're interested in trying the game out, you can check out the link. And if you run into any problems in terms of design or you don't know what to do, you can ask the Discord. There's a lot of helpful people there. A lot of people have become nerds. There's some basic combat, but it's not too impressive. Okay, right, back to our Runge Kuda 7th Order mess right here. So if you didn't know, we are currently upgrading the analytical systems in this game. So my old analytical systems are a bit wacky. They kind of work. Kind of, which is obviously not good enough. Alright. So I'm currently translating Python code from my new developer. New team member here. Phoenix. He created the Phoenix internal ballistic calculator. Or simulator. Rather. He's been really helpful. So I want to go implement this. Yeah, first I have to implement the Runge Kuda analysis. It's kind of crazy. Apparently my friends in computer science know about Runge Kuda. But me as an engineer, not yet. I don't need to know that, apparently. At least I'm not taking those courses. Also the Euler method. Euler method is also interesting. Okay. So this is going to be T science. So most Runge Kuda that you see is 4th order, especially in fluid, basic fluid dynamic simulations that you see on GitHub. But yeah, so something as complicated as internal ballistics, we kind of need to do 7th or 8th order Runge Kuda, especially for air, because that's very important. And the reason why we need Runge Kuda is because we're doing nonlinear analysis. So we can't exactly use a function and then pinpoint and then go backwards, because that's just bad. Yeah, I'm really impressed by Phoenix's work. It's the only Runge Kuda of 7th and 8th order right now available online is like on Fortran. And yeah, Phoenix came up with an entirely his own method, which is really nice. Still implemented from the original NASA paper. Okay. So I lost where I am. Okay. Y minus Y hat. My next J. Yeah, so that's that equation. Okay. Okay, so once we're done with that part, I think I'm missing something. Oh, I don't have an accept. Okay. It's gonna be another 13 length array. Fourth order wrench cutter only has 4, I believe. Once the end of the 7th, 8th, 8th order, it goes into 13 specifically. It's gonna be RSJ. The absolute. Gonna be E, so that's gonna be TE. J. Multiply this by. This is the upper limit of the integrand minus the lower limit of the integrand. Vector relative error specification, comparing the global extrapolated error to the smaller of the current next values. Okay, that's cool. So we're gonna do bar r equals 0. So now we're going to calculate the error, which is something. Ry zip. What? Huh? Do I have an adept? Yeah, I don't need this one. So adept is a new thing. Okay, this is kind of... This is definitely one of the things of all time. How does Python syntax work? This is kind of stupid. Phoenix, where are you? Okay, so you have a for loop. For I range. R equals RS I. I keep translating into C++. Okay. That was singular line of Python. What is this? It can do all of that? On the base of type bool. Yeah, I'm not sure why we need adapt to. So let's just if adapt. Okay. So adapt to can be a boolean. So if we see the test case, what's the test case for this one? Yeah, we look here. It's in main, and you write results. Okay. Abs to L, that's gonna be 1e minus 3. Okay. It's just a boolean. Yeah, so I don't see anything else modifying it in this thing, in this context. What the f- So it's up here, so it's after RM val. Okay, I guess we need this one. So if adapt to var adapt to array. It's for I in eval. For I in range. This part's pretty sad. And true. This one's adapt to that true. Alright, so let's go back to the actual implementation. So now that we have that, var RMY equals what? What is that? Absolute length arm. Divide this into 1 plus x 1 to 1 times min x y1 There's a max here. Okay, so it's still within the max. Okay, so this is still within the max. Abs 2, 1. So if adapt is true, then we do our so we just need to do this. So that's going to be our tolerance here. Just copy the comment from Phoenix. So yeah, I'm not stealing code. It's just from our new developer. I might be coping, but that's the truth. Okay. We generated a relative error estimation for each component to take the extrapolated global error, divided by the least of concurrent and the future estimates, or the mostly the interpretation. Okay. Thank you. Var delta. This is our step size. It actually reminds me like a bit of machine learning, but yeah, I've also done a lot of boot-like functions like this before with step size. Branch kata in. Okay. We kind of made it already. Hopefully that's not integer division. Oh, we have an exponent as well. Okay. Now, Let's move power to 1/8. Interesting. Okay. What else? Why next? X plus equals H. Okay, so RM, I in range, RM dot size. This is already an array, so we can do RM. It's gonna be the max of. It's gonna either replace with RM or RS, depending on their size. Interesting. Hey Creepy, we are implementing wrench kata. Seventh to 8th order wrench kata precisely. Phoenix made a new version for me because I was struggling with the one that he provided in Pips. This is just optimized and doesn't make any sense, especially when it comes to translating it to GD script. This is weird. Oh, the abort function is an actual function. Okay. You put blank on a... Let me try to fix this, because Python is so different in that regard. Okay. Yeah, I'm not sure how to do this, man. I'll just scan the rest of the code to see if there's any RKF. Why do I have so many viewers for this stream? I did not mean for it to be like this, but hey everyone. Have abort function condition here, but currently don't know how to implement null function in GDScript. Okay, let's just skip that part for now. And X, Y this. If R not equal to 0, size according to composite error method. So over R. It's 1/7 now. Okay, fair. Else. That's pretty obvious, but game. Yeah, so a bunch of stuff in here. Oh, so still in the error is acceptable part. Okay. It might be. Because Pit's still a lot of integration, right? So they might have to do a lot of fast integration stuff, so it's quite similar. Although I don't think Pit uses especially this level of wrench kata. If it's something easier, they could definitely use the Euler method of solving. Okay, Phoenix says. Yeah, is the same dimension as the input data. Okay, I'll go fix that after. Is input data. Physical meaning of the partial derivative of the system with regard to a variable. Same dimensionality as y. Or fix that. Let's go back. I have to fix something. Alright, let's see the Python implementation. Okay, di equals defunc xi. Is the size of I different? Oh, okay. Yeah, it might be stupid. Makes sense, makes sense. Such that ki is in di. Okay. I have to fix that. This one, I think. Level Y. Okay, set these YI. Trace back. Okay. Thanks, Phoenix. Let's go wind up. Yeah, interesting topics for sure. Personally, don't have much experience in this type of stuff. This is a pretty careless error of me. Append. Okay, so that's fixed. That's DI, that's size. I have to do this code pass through again. No. Whatever. There's a resize function. Might be a bit too sleepy to implement that though. I'd rather not. Rather not die. Okay. That makes more sense. DS equals I. Is there anything else that's reliant? Alright, I'll do a little snipping tool of this. Send it over. Yeah, PIDs love percentages. I worked with PIDs a lot as well. We had a robot that I had to build. Yeah, PID is like a lot more real-life application compared to in-game. As for FTD, it helps quite a bit, but it's a bit different. Oh, okay, we have a new issue. Put in a struct, get a script array of results, then I would have to change the func. Okay, so hopefully I fixed everything properly. Min-max, literally. Multivariate example. Multivariate example though, see above multivariate example, where this is called an issue. Partial derivative at points x, y1, y2 is a really function. Okay. Try to fit that in. Let me see. Take some time to understand this. The math is definitely not fast. Okay, so we have C bar not equal to 0 and V bar greater than 0. Gamma, LSPD bar. Okay, how would I implement that though? Real question. This is so stupid. Okay, so why I, the initial inputs. Initial values for y2, y3. Hi, Phoenix. Yeah. Oh, it's Phoenix. Like, wait, who is that? Okay, yeah. So I'm trying to figure out how to actually implement that. Because in Python it's definitely easy, but here it's not. So what's the range of things that DI is supposed to be? This is the most basic approach, but defunc, trying to struct array of results. Yeah, no. I'm just struggling to figure out how I can do both the simple one and the complex one at the same time. Like, how would I do that? I'll just put in the code beside for reference for myself right here. Python is a bit too flexible. Xi, xy, h. So that's a struct. Alright. What's the range of di? How many dimensions can di be? So in the example they gave me of ODE1, that one is a dimension of... Is that a 2D array of 3? 2 times 3? The 2D array with three things inside. Okay. Be able to return oh, why I is equivalent to. Yeah, that makes sense. So we must be able to handle this case. And then we have the simple case as well. Okay, so let's just put everything into an array, I think. So defunct is with all the arguments? Okay, that makes some sense. So like in the example you gave me here, might want to save that. Let me save that first. I didn't dox myself. Holy shit. It's crazy. Okay. Okay, so in this case, yi would be so this is correct, right? So for this particular function, yi is going to be y1, y2, y3, right? Okay, that makes sense. Yeah, how do I do this? Okay. Okay, I know how to do this. So how we do this is that I have to change every single function. That's the only way we can do it. So in the actual function, we're gonna replace ordinary differential equation. It's kind of it's creepy. So what we're gonna have to do is that we're gonna have to convert this into one array. Inputs. Yeah, so this is what we're going to have to do in the future, Phoenix. We have to convert all of the conditions that we want in the ordinary differential equations into a single input array. That's how it usually works in other languages, like Go. So that's what we have to keep in mind to kind of make that work. I was like, wait a second, I did something like this before. Okay. So we don't do this then. So di is gonna be empty. Wait. So just to clarify, yi is the same as... So di is going to be also, like, just a one result, right? Hopefully I'm understanding that correctly. So di in this case is only going to be dt bar, dz, and dv bar, right? Okay. Alright, so I don't need this entire thing. Great. I'm glad I'm actually understanding this stuff. Okay, so this is going to be a single function call then. Yeah. I think that's a name I found. Okay, so it's just going to be this then. This is our current streamlined output. Okay. So ki is going to be similar. Do I have... what's ki supposed to be? H times d, or d and di. Okay. What's this supposed to be? Okay, so ki equals... Okay, so yeah, that's going to be blank. It's going to be di.size. This was going to be ki... Here we have to do ki dot append. It's supposed to be h. Okay, hopefully that works. Alright. So that should be the proper way to implement that. Hopefully I don't get anything else. I didn't get anything else wrong. That was very major. All these kind of follow it, so... Okay. Let's continue on. Okay. Yeah, we might have to write some unit tests for this. I said earlier that it didn't, but apparently not. I definitely need some. And this is the debug code. So actually, let's actually put it in. I'm a bit scared. You can actually just bring it over. This part's just completely copyable. Oh, have these as commas? Know that. I should know that though, because I just did a CLI console in Python. That's weird. Oh, some tabbing issues? Okay. Okay, it's quite a bit. Let's properly keep these floats warm and comfy. Oh, I think I have to do a call. Alright. That's how we do a callable function pass-through in Godot. Actually, the last version, you couldn't even do a function pass-through. This is pretty new, groundbreaking stuff. Thank you, Phoenix. Yeah, so for returns like this, we also have to package it as a array. Not sure if this works. Multiple. What's going on? Godot multiple return. Oh. I think I searched this up yesterday. Or dictionary, okay. Factor is an object. Maybe. I'm not sure. Hopefully this works though. Doing it in function form is a bit complicated. Alright, so this should be good. Wow, we finally have RK. Wrench could have done. It's crazy. Let's pull a function from here. Wait, where's my function? It's the easiest test case to use. Let's just simply... Let's implement... Yeah, here we can do it in a dictionary or array form as well, in case we want to handle that. So it's not super terrible. I've returned a lot of arrays before. I'm getting so many views on this stream. What's happening? This is supposed to be a niche stream for nerds. $50 views? It's crazy. I get like 10 usually. Okay. X, Y. In this case, it's gonna be like this. Whoops. Even then, it's still only 2 views. It's not everyone jumping it at once. X0. Okay. What do you mean expected parameter range? Wait, why is this Okay, something weird happened. Oh. Wait. What? What's happening? I'm a bit confused. It apparently can't be an underscore, okay. EF1, XY blank. Return like bar temp result. Okay, now it's time for the moment of truth. So that's gonna be our second input. Third input, fourth input. Where did Reltol go? Okay, now I have to search out how to handle conditional arguments in Godot. How to handle conditional arguments. Godot. Yeah, don't know how this works. Oh, I have to put in all the parameters. Okay. If I want to have optional parameters. That's really annoying. 0. -3. Okay. So we're definitely gonna have bugs. This is definitely not gonna work on the first try. Because that's... if it does, that's crazy. It's technically hard code these. We could. What needs tweaking though? There's something that... because the user is going to input the book true? Okay. Adapt to 0 by 0. Yeah, so in Godot we have to do this. This is kind of stupid, but how it is. Okay, project settings. Okay, let's auto load.
酔いが覚めない夜グラスの氷揺らしながらまた戸締まりを待って帰りの準備終電待ち気のままに踊れば朝まで割らない少しずつ少しずつ心から
Yeah, so it's kind of running that process. So you just have to wait for it. We've turned the Godot engine into a console. How long is this supposed to take in Python? Something's probably wrong. Let's just check if we did anything wrong first. Code proofreading. Oh. I think we accidentally made an infinite loop. Or accidentally made an infinite loop. Okay, it's stuck here. Alright. Let's start debugging! Yay! One big thing I love about the Godot editor is the filter stack. This is so beautiful. Yikes, creepy. Yeah. That's a certified climate change moment. I probably just wrote something incorrectly. Let's just check that first. I think I didn't replace this one with the new one, or the old one? Who knows? Oh, and also this is supposed to be inside the while loop as well. Yeah. That's not supposed to happen either. That's good. AC is a dream. Or h is less than 0, and x is greater than x1. Oh, okay. Yeah, that's just because I didn't have the condition. Let me try to figure out how far this goes for. Okay, until... Yeah, I just don't have the exit condition, so
そんなこんなで落ち込むわけじゃ誰かに評価されてると自分らしく
okay, let's check again.
変わらなくちゃふっと思い出すあなたのことが思い出にまたしたくないんだ立ち向かうその姿が憧れた幸せそうな顔したまま生きていたとこ
Maybe, yeah, T is probably not supposed to be like this.
わかってるのに答えは一つの世界じゃつまらなくし
Where is TE?
比べることも意味なんてない手探りながら生きている僕
Yeah, this one's not supposed to be that big.
最高に素敵で輝いてるよ
For y next dot size. It's a bit about artifacts. I see. Is RS not also not supposed to be that? Let's see. Yes, that's based on TE dot size. This is the exact same issue. TE size. It works! What? No way. Nothing printed in the debug, so that's probably a good thing. Let's print. Apparently you want number 1 and 2. Okay. That's a small issue. I don't think we're supposed to be getting these results. So we want Y, this, and RM, right?
が落ちる頃にはきっと嫌な気持ちも消え去って
Okay, so it didn't run. This is gonna be one of the debugging moments of all time. What information do we need? Why next? Okay, start from the top. We have breakpoints if we need to use them. Put the breakpoint here. Okay, so we have our filter stack here. H became -4. Okay, turn package. Okay. Let's run it to the next breakpoint. Okay, yeah, so that's not showing up. What could be the problem here? Yeah, bug is true. X is x0, y this is inval. Eta is 0.84. H is x1, x0. We actually have breakpoints in Visual Studio Code. Yeah, so I'm guessing RM is working, otherwise it would crash. Adapt to array. If adapt to. Becomes a true array. So we're not using sig because we're not doing that. Okay, is this? Maybe that's part of the issue. Is OK supposed to store arrays, or what does it do? Actually, I wonder what I'm having OK doing. Oh, it's actually holding stuff inside though. It's all holding negative numbers. Interesting. Maybe we could change that into 0. Yeah, I'll send over that file. Battleship shells? Probably not really. Honestly, things aren't gonna get very accurate. It's gonna be like really consistent results that make sense, make some sense, but I don't think it's ever gonna reach that level of accuracy. Definitely gonna have that unique Rixas feel though. Yeah, I think that I'm gonna definitely set up a Git and start work on that. At the moment, okay, let's break that down. I'm actually completely done with this for today. I'm not even sure if I was supposed to be working on this at this time. It's 2 in the morning. Okay. I don't think my brain should be able to handle that, but regardless. Battleship shells. Battleship shells can pen a lot. Let's actually try to create something. Yeah, I'm a bit smoked. Usually when I do these streams I do low intensity work so I can chat with people, but yeah, today this one definitely consumed all of my energy that I had left. Alright everyone, have a great day. See you all later.